Tactical nuclear warfare on land. 50% of all nuclear weapons were deployed for tactical nuclear warfare. On the left, you can see a US Lance missile. On the right, a Scud missile. So how useful are tactical nuclear weapons? Well, tactical nuclear weapons are nuclear weapons designed for battlefield use. They're smaller warheads. They tend to be flexible and they have shorter delivery systems. The U.S. arsenal in 1984 had over 5,000 tactical nuclear warheads, including 610 backpack nukes, which are ADMs, atomic demolition munitions. In 1964, an atomic demolition munition unit was 163 pounds, or 74 kilos, and it consisted of a 26.6 kilogram warhead, which were man-portable. You can see here U.S. troops engaged in operations next to a nuclear detonation, just to show how close soldiers would operate next to a nuclear blast. On the left, you can see a U.S. Davy Crockett W-54 120/150 millimeter recoilless rifle with a W-54 warhead. These are other deployments of the Davy Crockett, which was fielded between 1961 and 1971. The Davy Crockett has a range of 2 to 4 kilometers. It's fired from a recoilless rifle, which is otherwise used as an anti-tank weapon. It can operate from a jeep with a 4-man crew. The W-54 warhead weighed 51 pounds and had a yield of 0.01 to 1 kiloton. In other words, 1,000 tons of TNT. 2,100 were produced for the cost of $540 million. Battalion commanders, a battalion is a military unit of around 500 soldiers, and lower, including company commanders who commanded 100 soldiers, had launch authority. This was designed with the view of a decentralized battlefield in mind, although U.S. civilian government analysts disliked it. They thought it was highly escalatory. They believed that the young soldiers would lose control and fire the nuclear weapons without authorization. These are soldiers that attended a nuclear test blast exercise. Here they're hiding in the trench. Here's the effect of a nuclear blast on soldiers in a trench. Enhanced radiation bombs, ERRBs. The problem was that Soviet armored forces had tanks and armored personnel carriers that were lined with lead to resist some of the radiation. So US developed the Enhanced Radiation Bomb, ERRB, or neutron bomb, in which fast neutrons would penetrate and microfragment the armor of Soviet tanks and kill the crews in a matter of hours or days. 80% of the energy released is gamma and X-ray radiation and neutron radiation, instead of the only 5% for thermonuclear devices. It also leaves little residual radiation from fission contaminants, thus permitting friendly troops to operate in the battlefield shortly thereafter. The design is in a normal single-stage fusion device with a deuterium and tritium kindling. If the depleted uranium mantle is omitted, then the high-energy fusion neutrons are released. An example of a neutron warhead is the US W-79 8-inch artillery shell. A 1 kiloton neutron bomb would send out 18,000 rads to 400 meters, and this would incapacitate people within 5 minutes. So everyone within half a kilometer would be killed. It would send out 8,000 rads to 650 meters. This would have an effect of burns and would affect most people and incapacitate them and kill them within 48 hours. It would send out 3,000 rads to 800 meters, which would be lethal within 5 days from radiation poisoning. And 650 rads out to 1,000 meters, which would have a high mortality rate in a period of over 2 weeks. It was normally estimated that 1 neutron bomb would be enough to neutralize 100 soldiers. This weapon would create about 10% of the physical damage of a bomb of an equivalent power. A comparison of fission and neutron bomb effects shows the size of the detonation of an enhanced radiation bomb versus a 10 kiloton fission bomb, with different burst heights and the distance in rads and the PSI. You can see that the PSI is about half for a 1 kiloton device if the burst height is 152 meters. But if the detonation is at half kilometer or a kilometer height, you basically have far less PSI damage from the enhanced radiation bomb. So you can see in the lower graphic the difference between a hydrogen detonation and the neutron warhead. You can see the mantle has been removed, allowing the flight of the fast neutrons for the neutron warhead. Tactical nuclear weapons have a variable yield or dial-and-nuke feature, which permits destroying enemy forces between friendly units or near vital infrastructure without damaging that infrastructure. For example, the US 155mm artillery howitzer shell had a variable yield of 0.05 or 0.08 or 0.1 kiloton. The US Honest John rocket had a dialable yield of 5, 10, 20, or 50 kilotons. The US held these warheads loosely for their NATO allies that had the different systems. The note is, US tactical nuclear weapons had permissive action links deployed on them because of their dispersion. US main battle tanks, armored personnel carriers, self-propelled artillery, and command vehicles all had integral nuclear biological chemical protection, which consisted of an overpressure system. If the vehicle was breached, the overpressure system pushed the air out so that radioactive materials did not come in. And there were filters against chemical, biological, and radiological contaminants that allowed air to filter into the vehicle. This here is a US M3 Bradley armored infantry fighting vehicle that was so equipped. Tactical nuclear launch systems. There are 4 types of tactical nuclear weapons. There are first air-droppable bombs. This is a Soviet-era Sukhoi-24 long-range bomber, the Sukhoi-24 Fencer. This is the MiG-29 fighter. This is the Sukhoi-27 fighter. This is a French aircraft, a Mirage, which carries underneath the French ASMP missile, which is a nuclear missile. This is a British Harrier deployed in an urban area. It was thought in a nuclear war all the airfields would be destroyed and aircraft would have to be redeployed along dispersed airfields, most likely adapted long highways. Vertical launch aircraft like the Harrier, which does not need an airfield, it can rise up like a helicopter, could deploy almost anywhere, including inside cities. The second system were artillery-launched nuclear weapons. Most of these are gun-design uranium-235 warheads. Soviet tactical nuclear weapons could be deployed by the 2S-5 or the 2S-3 out to 27 kilometers, and they had a variable yield of between 1.1 to 5 to 2 to 5 kilotons. Soviet divisional assets also included the 2S-7 howitzer and the 2S-4 mortar, which had 18 and 12.7 kilometers range respectively. You can see in the chart the different types of Soviet artillery. Some were capable, some were not. This is the Soviet M1974 2S1 122mm self-propelled gun, which was not thought to be nuclear capable, but might have been. This is the 1973 2S 152mm self-propelled howitzer, nuclear capable. This is the Soviet 2S5 152mm SP self-propelled gun, nuclear capable. This is the Soviet 2S7 203mm M1975 gun, nuclear capable. This is the Russian 2S9 152mm nuclear capable artillery. This is US tactical nuclear launch systems. US nuclear artillery within NATO numbered 4,300. This included the M109 used by Canada. The US M109 was a 155mm artillery piece with a range of 18 kilometers and could fire a 1 kiloton warhead. The US M110 175mm could fire a 0.5 to 10 kiloton variable yield warhead to 16.8 kilometers. The People's Liberation Army had a towed 152mm howitzer, which was the Soviet equivalent of a D-1, and a Type 66 towed 152mm howitzer, which is the equivalent of the Soviet D-20, which were thought to be nuclear capable. The West Germans had nuclear 155mm units located at the divisional and lower level because the Germans spent a significant amount of time conceptualizing how to integrate tactical nuclear firing along with their maneuver forces. Because they were fighting for their country, they took defense very seriously. On top is a US M110 175mm self-propelled gun. The lower image is of a NATO platform with a large cannon that is probably mid-Cold War era. Very likely nuclear. This is a US 8-inch artillery piece that was nuclear capable. The third type of launching system are battlefield missiles. These are typically very hard to locate. For example, during the 1991 war, the US allocated a large part of its air force to destroying Iraqi Scuds that were being launched at Saudi Arabia and Israel. It's still uncertain as to whether they found any. On the left is a US Lance missile. 2,133 were manufactured for NATO between 1971 and 1980. It had a range of 110 kilometers, which made it a theater weapon, and it had a variable yield warhead of 1 to 100 kilotons. You can see on the right the French Pluton rocket. The Pluton rocket had a range of 120 kilometers and a 15 to 25 kiloton warhead and could operate a neutron bomb. The US also had a theater missile system, the ground-launched cruise missiles, of which they had 464 and 108 Persian IIs. And the US also operated 200 surface-to-air missile launchers, typically the Nike Hercules system, that could operate nuclear warheads. This is a US Honest John missile in the Jeep launch trailer. This is the Honest John missile on a truck launch system. This is the US Lance being set up for launch and launched from a tracked launcher. This is a concept for mobility for the US ground-launched cruise missiles. Ultimately, the US put the cruise missiles in fixed bases because a lot of people didn't want nuclear missiles driving on the highways of Holland and Belgium. This is the US MLRS, Multiple Launch Rocket System, which is a tactical launch system, but it has an ATACMS system, which is long-range rockets that go to 100 or 200 kilometers that are nuclear capable. This is a chart of Soviet short-range or theater-range missiles. The Frog on the left was the first system developed in the 1950s, the free rocket over ground, and you can see the SS-21, the SS-1 Scud-B, the SS-23, and the scale board. The scale board is depicted at the bottom on parade during the Soviet era. On top you can see the Frog launchers as a part of the GDR, the German Democratic Republic's army. Below is the SS-21 Scarab missile system with the missile inside the vehicle. This is another depiction of the Frog 7 rocket. A Frog 7 rocket in preparation for launch. These are the geodesic or the geodetic teams preparing for launch. They have to measure the shape of the Earth in order for the rocket to go where it's supposed to go. This is the Indian Prithvi missile, their first missile with a warhead. That is a very short-range missile, and therefore it was converted into a tactical nuclear missile. Although it's probably still being targeted at cities, because India probably lacks the command and control to be able to hit moving ground targets. This is the US nuclear-capable Little John surface-to-air missile system that had nuclear warheads. This is a US Air Force F-101 firing a nuclear-tipped Genie air-to-air missile. The Genie and the Falcon air-to-air missile were the two nuclear missiles in the US and NATO arsenals. They were first tested in 1957. They were unguided missiles. 10,171 Genies were manufactured, and 1,900 Falcons were manufactured starting in 1961. You also had human-delivered systems, the atomic demolition munition, which are currently withdrawn from Western arsenals. On the left, you can see Soviet nuclear, biological, chemical weapons detection troops. They move around in scout vehicles, and they detect and then map out contaminated areas so they can avoid them, if possible. On the right is a U.S. Pershing theater missile system with a circular error probability of 30 meters. So how do you use tactical nuclear weapons? Tactical nuclear weapons use. Points for tactical nuclear targeting. 1. Nuclear attacks must be launched with care for friendly forces. There are plenty of instances in World War II where bombers and artillery attacked friendly troops by accident because of communications error and misunderstanding. During the breakout from Normandy, a U.S. heavy bomber attack killed a U.S. general and his staff. Number 2, reconnaissance must not only locate but keep track of targets. The modern battlefield is very fluid. Soviet tank formations move at 30 kilometers an hour every hour for days. Number 3, you have to suppress enemy nuclear launches. One of the missions of artillery is counter-battery. Artillery shooting at other artillery, which is why artillery is self-propelled. They have their own vehicles to move the artillery around because they have to shoot and then scoot. Because radar detects the geometry of the shells coming in that they fired, and then other artillery fires back at where they were. With tactical nuclear weapons, it'll be more difficult to escape once you fire your shells. Here you can see a U.S. Honest John launch, and you can see the propellants at the top adjusting its direction. Number 4, target for maximum enemy destruction. Hit targets in depth like headquarters units. Number 5, take advantage of the great blast radius to have an area effect on dispersed units. Number 6, limit the diminishing marginal returns of additional nuclear weapons launched. You don't have an unlimited supply of nuclear weapons, so launch them carefully. Number 7, conduct battle damage assessment to evaluate the results of a strike. Otherwise, you won't know if you missed or not. This is a picture of a Pershing 1 missile, which were mobile, moving through a town in West Germany. The left is a depiction of the Soviet likely corridors of advance into West Germany. And these are the areas that are most likely to have seen tactical nuclear warfare developed. The West Germans would have liked to begin tactical nuclear warfare on the border of East Germany to stop the invasion. The Americans would have preferred to negotiate while they withdrew and contained the Soviets, and only use nuclear weapons as a last resort if the Soviets were about to get to the Rhine. You can see a depiction of the broader plans on the right, but I suspect those are more fantasy/paranoia than likely. This is the actual plans drafted to direct the Polish communist armies in support of a Soviet invasion of Western Europe, as released by the Polish army after the end of the Cold War. Points for battlefield survival. Number 1, disperse friendly units. In the 1950s, the U.S., anticipating a large nuclear war, reorganized the U.S. Army Division. A U.S. Army Division normally consists of 15,000 soldiers organized into 3 brigades, each brigade comprising 3 battalions, each battalion comprising 3 companies, plus support brigades of aviation, artillery, communications, and other elements like armor. The U.S. reorganized that into a much more dispersed unit with 5 smaller brigades that had all of their own components, so they were effectively independent. The logic was in a nuclear war, the modern division was too concentrated and therefore would be vulnerable to destruction. However, during the Vietnam War, the U.S. had to reorganize their divisions in more conventional ways, in the World War II style, and they never reverted back to the Potomac Division. They basically concluded that the divisions would have to do their best because they couldn't fight as effectively against conventional forces if they were in the Potomac configuration. In the 1950s, the U.S. reorganized these because of exercises that were conducted. But Vietnam experience concluded that it wasn't worthwhile. An exercise in 1965 indicated that the U.S. Army's divisions would have to disperse to 250% of how they were dispersed during the Second World War. In the Second World War, a typical division had a frontage of 15 to 20 kilometers. During the 1965 exercise, a division of 15,000 soldiers had a depth of 50 kilometers and a frontage of 50 kilometers. You can see in the chart below the various densities in frontage of different sized units for different countries. So for the Americans, a division had 15 to 20 kilometer frontage. For the British, it was 12 to 20. And for the West Germans, it was 20 to 25. Number 2, digging friendly units in works, including taking refuge in built-up areas like cities. It was the Tizard report, and Tizard was a scientist working for the British in 1946, and a subsequent report in 1953 that showed that dug-in soldiers could significantly reduce the blast effects of a nuclear detonation. In other words, if you dig a trench, you could be vulnerable to a detonation in the air. But if you dig a trench and then you put OHP or overhead cover, which is typically consists of a plastic kit with metal spikes that go into the ground, and that then creates the surface for you to be able to put pieces of wood and earth on top of it. If you could get 12 inches of overhead solid cover in your trench, then you increase your survivability to 95%, where you otherwise would have been hurt. So using the shovel and the ground to protect yourself against nuclear blast and dispersing yourself works. It significantly increases your survivability. Nuclear weapons to destroy ground units are not that effective if the ground units are dug in. You're going to have to use ground bursts, and you're going to create significant amounts of fallout. Number 3, anticipate the loss of communications during a nuclear exchange. You're going to have a lot of electromagnetic disruption. Services like artillery that depend on spotters, or aircraft that depend on ground control crews to tell them where to bomb, are going to have to come up with other means. Number 4, there will be almost no likelihood of nuclear weapons replenishment during a two-way tactical nuclear exchange except from out-of-theater forces. So airplanes can fly in from outside and drop a bomb and go back, but no ship is going to arrive with a big box of tactical nuclear warheads. You're going to be fighting with whatever you started with. 5, tactical aircraft will have limited availability as airfields will probably be wiped out. VTOL aircraft that take off like helicopters, vertical takeoff and landing aircraft, will be very useful. Below is a picture of a Soviet Frog launcher. This is a map of the airfields in Europe, almost all of which would have been destroyed. You can see a US ground-launched cruise missile being launched. This is a plan of a NATO attack on a Soviet army. So with a given inventory of 100 nuclear weapons, these would be the likely targets. 30 nuclear warheads would be used to destroy and identify suspected enemy means of delivering nuclear weapons. This is the counter-battery mission, artillery versus artillery. This would target missile, artillery, and air force elements. It is very difficult to locate these forces because they're mobile. 30 nuclear warheads would be used against headquarters units, of which there are about 30 for each battalion in a corps, because you've got 30 battalions in a corps of around 50,000 soldiers. Most of these will be located using electronic means, and these are consequently very difficult to distinguish from dummy radio traffic. So you could have a vehicle with a lot of transmitters, and it'll pretend and look like a battalion, and nuclear weapons will be fired at that location, basically wasting large amounts of nuclear warheads. 20 nuclear warheads will be deployed against 24 supply depots and infrastructure bottlenecks like bridges. Armies cannot fight without food and fuel, or bullets. 20 nuclear warheads will be deployed against those ground units that are identified. There are about 30 battalions in a corps, but not all of those will be operating up front, and so you'd be firing these for those enemy units that you're in contact with, but are not so close that you'd be damaged by detonation. So half of these units will be out of contact. The observation here is that only 20% of the nuclear warheads will actually be fired at frontline ground units. Most of them will be fired at in-depth support elements that make the front units able to advance. So this is the graph. You can see Erfurt In the top left, you can see Jenna. In the top right, I've got here both NATO symbology as well as cute little pictures, so you can see what kind of units are deployed where. This is full information. It's very unlikely NATO forces will see all of this. They'll probably only see the units they're in contact with, which are on the left side. So this would be the disposition of the 100 nuclear weapons. You can see the strikes occurring against some of the frontline units, but most of the strikes are in depth against artillery units, support communications, electronic warfare units. The anticipated losses in this particular instance of the use of nuclear weapons, which is against a core-sized unit, would be 30,200 casualties, which is 55% of the total, of which, because they're advancing, would be 20,250 in the open and 9,950 under cover. The forces under cover would mostly be the headquarters, the command and control, the communications, logistics, and artillery. 10% of the total non-armored vehicles, 1,050 trucks, would be damaged or destroyed. This is a logistic network, and most of the logistics network goes much deeper behind the core. 600 armored vehicles, or 18% of the total, would be destroyed. 141,800 civilian casualties would occur of those in the area, and those include probably a large number of dead. 567,100 civilians would be rendered homeless. 200,000 homes would be damaged and destroyed. Here you can see a Pershing 1, the joint US-American missile system. The Soviet Doctrine of Use. The Soviet emphasis was on mechanized warfare, and it had a lot to do with surviving the nuclear environment. The Soviet goal in a war was to capture as much real estate as possible by advancing as quickly as possible, because the Soviets believed that the tempo of operations was key to success in defeating Nazi Germany in World War II. So the armored vehicles are hermetically sealed with lead so that the soldiers inside can resist to some extent a nuclear environment. And then the Soviets would drive down the highway and try to make it towards the Rhine and engage NATO units. This here is a Soviet T-72, which had lead lining. It was one of these vehicles I got to jump into in Canadian Forces Base Valcartier. Characteristics of the nuclear battlefield. 1. Conquest of territory still matters, according to the Soviets. 2. There is no continuous front, so you have to have all-round defense at all echelons. If you form a continuous front, the enemy will know where you are and will easily nuke you. 3. Mobile and area defense is logical, as linear and point defense is very vulnerable. 4. Camouflage, communications discipline, dummy targets, and diversion are key to avoiding nuclear strikes. Here in the picture you can see on the left the US Honest John theater weapon, and on the right the British Blue Water theater nuclear weapon. Number 5. The breakthrough, which is where you break through the enemy's front line, and the hasty attack from the march, where you're driving down a road, you identify an enemy, and you very quickly plan an attack. You do not spend an hour, you do not spend a day planning the attack, but you attack immediately. This will be a lot more frequent than deliberate attacks. Deliberate attacks are where you stop and you spend several hours calling up artillery and engineers and infantry, and you rehearse the attack, and then you conduct it. Number 6. Destruction of enemy reconnaissance elements are imperative. Reconnaissance is the act of driving around in light vehicles and drones and helicopters and looking for the enemy. It's the eyes of the army. If you can destroy the reconnaissance element, the enemy will not know where you are. Number 7. In the nuclear environment, you're not going to get large aircraft flotillas and large aircraft packages where you've got 3 interceptors, 3 surface-to-air missile defense suppression aircraft, electronic warfare aircraft, several different kinds of bombers, and then the fighter escorts and interceptors. You're going to get individual aircraft because the large airfields will be destroyed, and so the large aircraft packages probably won't be possible. Number 8. Coordinating logistics is important. You need to get resupplied. So the logistic network to survive must be more dispersed, but they still have to be responsive. They have to drive up to a lagger, which is when you take your tanks and put them in a circle so they can get resupplied, and then they have to go back and get more supplies, and the unit has to move on. Because if they stay, they could get identified and nuked. During the 1954 Soviet nuclear exercise in the Carpathian Mountains, it didn't detonate any nuclear weapons, but it was notional, between 2 equal sides using tactical nuclear weapons, it was found that ground operations, rather than being very, very fast, actually ground down to a halt like the First World War. in part because all of the logistical sites were destroyed. So military units could continue to survive and fight, but it resembled more the First World War than it did the fluid maneuvering of the Second World War. You can see on the left Soviet tracked frog launchers, and on the right you can see a US tracked Lance missile launcher. Soviet tactical nuclear doctrine. 1. Nuclear weapons permit offensive operations at a high rate of advance because the rate of enemy destruction and the benefits of surprise. So if you have nuclear weapons and you're destroying targets as you're coming in contact with them, it allows your army to continue to move quickly down the highway. Number 2. Nuclear weapons complete the destruction mission independently of land forces. This is a very big assumption. It's the assumption that was false in the World War I. The idea that if you put 1,000 artillery shells on a unit, the unit would disintegrate and you simply have to walk through. In World War I, that was repeatedly falsified because people can dig in and protect themselves, and when you show up, they surprise you and you're in the open and you die. But the Soviets believe that with nuclear weapons, finally, this problem has been solved. And so you can blow up an area and then you don't have to go there and kill the remainders because all the remainders will be dead. I am very skeptical. Number 3. Nuclear fires must be exploited by maneuver forces. Once you destroy a target, you open up geographic area and you've got to move in vehicles to be able to get control of that territory. Number 4. Reconnaissance forces must find a path immediately after a nuclear strike and lead the other forces that must pass quickly through the contaminated area. When you use nuclear weapons, you're going to be throwing around a lot of debris, collapsing buildings over highways and putting craters in places. This means that old paths that were open are now closed. So reconnaissance elements must keep the units moving. If units stop in long columns, densely packed on a highway, they will get nuked. So any column that stops or is delayed or is slowed down in a traffic jam will likely be destroyed. So you never want to stop moving. This here is a picture of Chinese troops, and they're wearing nuclear, biological, chemical weapons protection suits. This is a chart of battlefield surface burst crater sizes based on the size of a nuclear weapon that's detonated on the surface. Some of these are enormous and would severely inhibit navigation. You can also see a Soviet crew setting up the telemetry for their missile launch. So tactics in a nuclear environment by the Soviets. 1. Isolate the battlefield. Hit the reserves. Create obstacles. Destroy roads. All with nuclear weapons. Isolate the battlefield means destroy all the roads around the battlefield so that the enemy in the battlefield can't get reinforcements. 2. Shift directions quickly to avoid enemy nuclear strikes. If you're driving down a straight road from one place to an obvious other place, someone will drop an atomic bomb on that road, even if they're not sure you're there. 3. Close with enemy troops. The closer you are to enemy troops, the less likely they are to nuke you. This was actually China's tactical doctrine. Because China was fearful that the Soviets would invade in 1980, and the Soviets had a fairly aggressive collection of armored units with artillery, nuclear artillery, the Soviets were going to drive across the border and push towards Beijing through the northern mountains. If you ever go to see the Wall of China, you'll see those mountains are pretty rugged. But the Soviets were going to push through and then take Beijing and nuke everything on the way. The Chinese military units would not have survived unless they closed with the Soviet units and were so close that the Soviet units could not nuke them without hurting themselves. Number 4. Nuclear attacks must be optimized to be used against targets of opportunity. So you have to have units that can be quickly called by radio because you might see a passing formation and know that it's moving so quickly it'll be gone in a short order. So you need to have artillery units that are ready to launch nuclear weapons on a moment's notice for these targets of opportunity. Number 5. You have to use special forces and airborne forces to attack enemy nuclear weapons. The bottom picture is of a Soviet Frog launch. Now in the graph you can see above, starting from left to right, you can see aircraft, which are second echelon forces, fly ahead with nuclear forces and they bomb enemy airfields with nuclear weapons. You can then see the SS-21 missiles, or the Frog, free rocket over ground rockets, that are firing missiles into the rear areas of the enemy. You can also see the 122 and 152 millimeter artillery firing rockets at the target. You'll see two semicircles going from the bottom to the top of that rectangle, which is called the FIBA. The FIBA is the forward extent of the battle area. It's the actual area where the two armies are engaged and shooting at each other. On the top of that, you can see the SS-23 or the Scud missiles. These are theater weapons. They're meant to destroy targets that are very deep on the battlefield, like command and control, and as you can see here, supply depots. The picture at the bottom is, of course, of a wheeled vehicle carrying a free rocket over ground. Now, the Soviets returned to the use of nuclear weapons doctrinally in 1988-1989 after NATO's improvements with precision-guided munitions. NATO became very efficient with laser-guided weapons, and the Soviets anticipated this. This was demonstrated in the 1991 Gulf War, where laser-guided weapons were able to destroy targets much more easily than gravity bombs. 1,528 to 2,714 nuclear weapons would have been used by the Soviets in an initial attack on NATO, and main forces would then have been deployed to avoid counterstrikes. Whereas NATO conceived of using nuclear weapons to hold back the Soviets and would eventually introduce nuclear weapons, standard doctrine for the Soviets was they would only start a war if they were desperate. If they were desperate, it was because they were about to be attacked. The lesson from World War II was never fight a war on your own land. Hitler killed 27 million Russians and destroyed 60% of industry. So always fight your war on someone else's land. So if the Soviets thought they were going to be attacked, they would have attacked with ground forces. But they would have attacked with everything. They would have attacked with strategic weapons and theater weapons and tactical nuclear weapons at the same time. The Soviet logic is nuclear war is bad, but it's not as bad as genocide. Since Hitler's plan was to wipe out all the Russians in European Russia and render them into some sort of slave population to serve German needs, the Russians had already experienced this. By occupying land and all the people on it, specifically Western Europe, the Russians felt that they could have then been impervious to being destroyed. And even though they would have suffered severely from a nuclear war, even in that state, by controlling Western Europe, they would have been able to resist any subsequent attack to destroy them. So let's think of some applications. Cold War Europe. NATO had a first-use declaration of nuclear weapons. Between 1956 and 1957, the U.S. Army requested 151,000 nuclear warheads for tactical use, of which 106,000 were for tactical battlefield use by the Army, 25,000 for air defense, and 20,000 assorted warheads for their allies. It was estimated that the Army would use 423 nuclear warheads a day in a tactical nuclear war, which did not include surface-to-air missiles. If you work it out, this would be just several weeks of nuclear weapons before NATO ran out. You can see at the bottom Soviet Scud units deploying in a forest, and you can see in the map the number of divisions that are armored deployed by the Soviets, which are in dark maroon, pink, which were deployed by Warsaw Pact allies, not completely reliable. And then you can see the other units deployed that were neutral, that are yellow in Yugoslavia, Sweden, and Finland, and the green forces, which are NATO. You can see a small half rectangle, which is Canada, near the Rhine, in the south west portion of West Germany, which in my view is very pathetic and typical Canadian. Each of these are a division. Each division is 15,000 soldiers. An armored division typically consists of 300 tanks. An infantry division consists of less tanks, but more infantry. Infantry are not weaker. They're just better able to operate in difficult terrain, like broken terrain in cities where tanks are very vulnerable. As you can see, NATO was very outnumbered, and it was one of the reasons why NATO had a first-use policy and was likely to act on it and deploy and fire nuclear weapons first. This is the amount of nuclear weapons required for theater use in Europe. Number of targets, for example, airfields in Eastern Europe, 170. Short-range missile sites in Eastern Europe would require 650 weapons to destroy those targets. Company-sized units at the front, 700. Division base in Eastern Europe, 90. So just for the number of targets was 1,610. This was calculated to require 2,014 targets. And then you have a list of the different weapons that could have facilitated this in a strike. So these are the total losses for a short engagement of all the forces in West Germany and the surrounding European areas like Denmark, Holland, Belgium. if the Soviets invaded West Germany. You're looking at 1.2 million soldiers, casualties, that's killed and wounded, 70% of the total. 43,000 non-armored vehicles, or 17% of the total. 15,000 armored vehicles, or 29% of the total. 5.6 million civilian casualties. 23 million homeless civilians. 8 million homes destroyed, and 30% of Germany's economy destroyed. Again, you've got a Soviet frog launching system. You can see the storage sites for nuclear weapons, military airfields, and surface air missile sites in both East and West Germany in the map on the top. And on the right, you can see the amount of rads, 200 to 600, which would be felt if nuclear weapons were used and targeted at those areas. At the bottom, you can see a French Pluton missile. The French Pluton missile had a neutron bomb warhead. The US conducted an exercise in 1965. And they found that there was only a 6% daily attrition rate if nuclear yield weapons of 35 kilotons were used, which is the typical weapon scales of tactical nuclear weapons. This was considered less than either the Napoleonic Wars or certain key First World War battles. In other words, using tactical nuclear weapons, while it would destroy very exposed targets like airfields and supply depots, if armies dispersed and basically dug in, with overhead protection, the war would resemble something like the First World War. This confirms the Soviet Army's 1965 exercise in the Carpathian Mountains, where they saw that the nuclear weapons application slowed down the tempo of operations and essentially led to static warfare. Now, I ran a NATO Warsaw Pact simulation, and I assumed that there were 21,000 tactical nuclear missiles available, including 11,200 nuclear missiles used for battlefield use. Of which 9,800 are destroyed or unused in 26 days of fighting. My calculation was that one nuclear volley by several batteries of artillery and airdrop bombs from aircraft or missiles consisted of 54 missiles and could destroy between 0 to 6 brigades, or 0 to 30,000 soldiers, depending on how they were targeted. Dispersion will be the result as much by deliberate decisions by the commanders as much by actually destroying formations and then de facto causing them to disperse. Most of the attacks would be against concentrations of initial Soviet breakthrough forces, would be highly concentrated. My findings were that the Soviets will likely grab the larger cities, knowing that if they go inside the urban center, NATO will be reluctant to blow up its own city. For example, the Soviets would very likely cross over and try to seize the cities of Hamburg and Hanover and Nuremberg, which are located relatively close to the East German border, and then to hold them as garrisons, hoping that NATO will not nuke these cities because the Soviets are holding the populations hostage. Nuclear attack would eliminate the Soviet Air Force. Theater-wide use of nuclear weapons would slow the follow-on forces from the Soviet Union as they went from reserve bases in the Soviet Union through Poland and through East Germany into West Germany. This is a frog launcher. Now, application of tactical nuclear weapons to the Cold War in the Persian Gulf. Following the Soviet invasion of Afghanistan in 1980 and the collapse of Iran, the U.S. president enunciated the Carter Doctrine, which committed the U.S. troops to resist the entry of any third party into the Persian Gulf, which is a vital oil-producing region. It was quickly determined that a purely conventional war was infeasible, and that tactical nuclear weapons would have to play a role. So, based on the 1950s Romeo option, which is the, quote, retardation of Soviet advances into Western Eurasia, close quote, a study was done to see what type of operations could be applied. So this included the nuking of Soviet infrastructure that would contribute to the support for an invasion of Iran. Now, it was expected that 10 Soviet divisions, each of 15,000 soldiers and between 100 to 300 tanks, would invade in 1968. And it was planned to use 200 nuclear weapons against theater targets to slow down an advance. A key role was going to be played by ADMs, which are atomic demolitions munitions. These are the nuclear demolitions charges, or the backpack nukes. And they would probably be deployed by special forces with engineer training. The US looked at ADMs and calculated that the Soviet Union could move 3,000 cubic meters of rock a day. Now, I'm an Army engineer, and I worked as a G2, which is a headquarters intelligence officer for the engineers. One of my jobs was to memorize, which I did quite successfully, the entire Soviet Army, including, not Soviet Army, the Soviet Corps, and I had to memorize each of the engineering components. For example, the Bat-M is an armored bulldozer. I had to memorize all the different kinds of these vehicles, where they were located, and what they could do. And I can tell you, because the Soviets were so determined to advance so quickly to conquer territory, they had huge engineering assets to build bridges, clear forests, rebuild roads, because they needed to keep the advance going. So the Soviets had a disproportionate amount of debris clearing engineer vehicles. So a 30 kiloton nuclear device can displace about 80,000 cubic meters of earth, and this indicated that nuclear attacks would seriously slow down a Soviet advance through the mountains of Iran for about a month, assuming that all the routes were hit. Atomic demolitions munitions would also produce fallout due to ground burst. One of the options was the use of cruise missiles from the Indian Ocean position so the United States Navy could deliver the warheads. Lance missiles, air-launched cruise missiles, air-dropped bombs, and nuclear artillery were also considered for use in the Zagros Mountains. So we would be looking at principally in advance from the Caucasus, right to Khuzestan. And here in the Zagros Mountains, you have passes. And a second advance to the Straits of Hormuz. And here there's, again, mountain passes that could be destroyed to the long. This is a chart from the earlier study showing the Eastern European targets that would have to be hit to inhibit the Soviet Union's ability to maintain logistical support for an attack into Iran. And if you look carefully, it includes the city of Budapest at the bottom of the list, which is actually not so close to Iran. So I ran a scenario and I applied it to operations of a nuclear nature between India and Pakistan. So I ran 3 scenarios. The first scenario was the use of a nuclear strike to break through the defense. I found it was useful but requires quick exploitation to avoid a counterstrike and contamination. Number 2, the use of a nuclear strike to halt an attack. The formations in the attack are more vulnerable as they are, of course, out of cover. And number 3, the use of nuclear strikes to cut logistics. The effects increase as the geography is infrastructurally constraining. Now, I chose the battlefield at Biratnagar, which is an area just south of Nepal. So I imagined Chinese mechanized forces coming out of Xinjiang, or Tibet, and driving towards the Ganges Valley in India, passing through Nepal, and then the Indians would confront them at Biratnagar, and then you'd have the sequence here of nuclear attacks. 1, the Chinese would use a nuclear attack to penetrate the Indian defense. 2, the Indians would use a nuclear strike to stop the Chinese advance. And then 3, the Indians would use a nuclear strike in the Himalayas to stop China's logistics support. So here I have the areas of damage for the nuclear weapons. I've got the different formations using NATO symbology, all done by hand. This is the logistical strike by the Indians in the Himalayas. So take a look at this map. We will visit it again in class.